Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ednis Rahmat. I can present my final year project titled Development of IoT Plant Monitoring System with Autonomous Irrigation Controller. So this is a proof of concept for the FYP. So the introduction for my FYP is this project is about a plant monitoring system that will help the farmers monitor and control plant condition by observing it through the Internet of Things technology. The development will help to track the environment conditions for irrigation control, such as temperature, soil moisture content, air humidity, and water level of agricultural land. The information collected continuously condition is likewise shipped off the cloud server for future stockpiling and decision making and control activities. So the problem statement for this project, firstly, is very time consuming. It makes the process more time consuming. For second problem statement, for manual monitoring, it's require field experts to monitor the site all the time. For the conventional irrigation strategies, when the irrigation system is manual, it may wet the plant, lower leaf and stem. Whole surface of the dirt is damp and at times stay wet even after the finish of water system. And condition advanced parasites live from disease. And lastly, inappropriate system for water control. The absence of automatic machine monitoring results in an inappropriate system for water control. So the objective of this project, first, to develop an IoT using Microsoft Azure Cloud Platform for the web server to display the data collected to help farmers monitor their crops from remote location. Second, to develop smart plant monitoring system using temperature sensor, air humidity sensor, and soil moisture sensor. Lastly, to develop autonomous irrigation system to prevent moisture stress in the plant with proper use of water resource. This my literature review for this project. I have covered three areas: IoT plant monitoring and irrigation control system. Secondly, controller type and specification, which I use Node MCU ESP8266. And lastly, the dashboard design I'm using is Microsoft Azure with the Power BI. So this project methodology, this is the project methodology process. Firstly, I identify the desired parameter need to be collected, which is temperature, air humidity, soil moisture sensor, soil moisture. Then I design the Node MCU circuit design, develop the Arduino IDE programming, Azure IoT Hub, and a website which is Power BI to display. So integrate the Node MCU with Azure IoT Hub, develop the autonomous irrigation system. So integrate the monitoring system with the autonomous irrigation system. Test the whole system, analyze the data, and is the end of the process. This is my hardware selection. I use Node MCU ESP8266 with Wi-Fi, DHT11 temperature and air and humidity sensor, soil YL69 soil moisture sensor, 5 volt DC pump motor, 5 single relay module, L298N, dual H-bridge motor controller. So this two software selection, I use Arduino IDE for programming to connect all the sensors and control the sensors, and Microsoft Azure IoT Hub as a hub to display and store the data collected from the sensor. This is my block diagram. So from the desired parameter need to be collected. So the soil moisture sensor will record the data for the soil, and DHT 11 temperature sensor and humidity sensor will collect the temperature and humidity parameter. So the flow from the soil moisture sensor and DHT 11 sensor are integrated to the Node MCU ESP8266 for the data. Then the collected data will be sent to Azure IoT Hub for the cloud storage, then sent to the website dashboard for the monitoring system. So the Node MCU ESP8266 will process the data to control the water pump for the autonomous irrigation system. So for the water irrigation system, this block diagram will show the flow water from the small water reservoir or the storage. Then it will go to the water pump, will suck the water into the hose. Then irrigation will do with the sprinkler. So this is the circuit for the project. So for the process flowchart, so the system consists of two units, sensor unit and the communication unit controller. So the sensor unit have three size sensor, which is soil moisture sensor, temperature sensor, and humidity sensor. So by measuring the electrical resistance, the soil moisture sensor senses the field and calculates the analog signal. If it was wet or dry, the resistance value determines the soil. If the resistance value is low, the soil will be wet, and if the resistance value is high, so the soil will be dry. So the signal from the sensor are sent in the form of digital signals to the microcontroller Node MCU ESP8266. Then the microcontroller Node MCU ESP8266 will send the data collected from the moisture sensor and DHT11 sensor to the storage and processing to the cloud. So the value sent will be processed with the reference value of specific crops variety cumulative by the farmers. So the value of the sensor will be continuously updated for the data processing in the cloud database in real time. So passes to the Azure IoT Hub server the data information collected from the sensor unit, and a website application which is dashboard is to track the irrigation system and all the sensors parameters. So this for the water irrigation system. So if the conditions is dry, soil is dry, so the water pump will turn on and will pump the water from the storage or the reservoir to a hose. If the desired parameter is not achieved yet, the water pump will always pump until the desired parameter achieved. So it will stop the pump. This is my Gantt chart for the planning and actual for my project development of IoT plant monitoring system and autonomous irrigation system. So the result and discussion. So the system has been tested and the result produced accordingly with the project if needed. The output is dependent on the parameter used to determine humidity, soil moisture content, and temperature. The reason I choose chili for the type of plant for this project because chili was suitable in temperature in Malaysia, which is from 20 to 30 degrees Celsius, with a rainfall between 1,500 millimeter to 2,000 millimeter monthly, and it can adapt to pH between 5.5 to 6.8 on mineral soil, peat or brick soil with proper irrigation system. So the reason chili was shown in Malaysia because it was major producing state, major producing plant in such state as Johor, Melaka, Perak and Kelantan. So the wiring system I using for the result, I use 2 power, which is 1 power from AC, which is converted using LM25696 DC-DC, a step down voltage converter, and for 5 volt for Arduino, not MCU, ESP8266. So DHT11, which is temperature and humidity sensor, using digital pin D4, using voltage 3 volt, and soil moisture sensor using data analog pin A0 and VCC 3 volt also. So this before we can process and store the data, we need to configure Azure IoT Hub. So this is an IoT Hub that I have been created, which is named ESP.MCU IoT FYP, and this is my account, Denish Rahmat at s.unikl. So data Azure IoT Hub is a paid app. So if I am a student, I have a free version for this IoT Hub as long as I am a student to UNIKL. So IoT Hub has 8,000 limit of data that can be stored only. So after we configure the Azure IoT Hub, we need to create IoT devices to receive the data from. So I create the device ID named ESP8266 and with the default parameters. After the IoT device configuration, I have the device ID and the primary key for used to as a key to process the data into the storage. So the result for this data processing, based on the data received from the node MCU, which is transferred to Azure block storage, which can be accessed with specific login ID, which is my account. So the data are collected of time at 12 hours data with interval 30 minutes. The table includes data for temperature, humidity and soil moisture. So when the data for the soil moisture sensor we receive as analog value, the value range of the output sensor may be evaluated from the 0 to 1024. So to calculate the data for the farmers, easy to understand, we use percentage of the soil moisture, and the calculation is the 100 minus ADC value times 100 divided by 1024, and the output for the dashboard will be in percentage of 100% or 0%. So after we done with the IDE, Arduino IDE, the data will transfer to Azure IoT using Wi-Fi. So it will display in the serial monitor to verify that Arduino have received the data from the sensors, which is temperature, 32.4, and so on. So after the Arduino receive the data and the data has been transferred to Azure IoT Hub, we need a container to store the data. So I use a block storage Azure container to store the data, and I name it as IoT container. And for the data to go one place to one place, I need a transportation, and stream analytic jobs is the transportation that transfer the data from one place to one place. So it use a query to move the data. As you can see the query, select cast IoT Hub as date time, as the event date, and send the temperature data to Power BI and to the block storage. And this is the interface I using the dashboard, which is the Power BI FYP. The demonstration for the project will be later presented. And this the data storage that have been stored to the block storage, as you can see as the time, temperature, humidity, and soil moisture. And we have also the soil moisture percentage that have been calculated. Okay, the limitation for this project is firstly this Azure IoT Hub need a subscription to be used, as mentioned. I have a student account. As long as a UNIKL student, I'm free to use. And the price is dependent on how many functions that the user want to use in the Azure IoT platform. So the crucial part is the Power BI cost for the data dashboard is expensive. I use $20 for my student credit, free student credit for the Power BI. So using Azure IoT platform need a strong Wi-Fi connection for the data need to be transport. If the network is unstable, the data will be sometimes lost and have a missing part. For the hardware limitation, they have fluctuation of data reading from the multiple sensors, and the third-party interruption also affect the sensors reading, such as seasonal conditions. So my recommendation for the next project. So for the software part, I recommend this project use an Azure SQL database rather than Azure block storage. Block storage is good for a big data, but it's an unstructured data. So compared to Azure SQL database, is a management portal itself and is at which service can be provisioned. The fact that service can be accessed as general availability prior to release. For the hardware part, this project can be improvised by adding the water level sensor to the water tank. To provision the water tank, it sends the alert to the user if the water reservoir is empty or low and need a refill. This project also need a security improvement For the unwanted variable like animal endangering the farm, an ultrasonic sensor and a speaker can be added as a security measure to avoid the unwanted variables. So for the conclusion, this project has set on benefit and drawbacks. Overall, the temperature and humidity sensor as well as the soil moisture sensor are tested in the irrigation monitoring and controller system to minimize malfunction, reducing the amount of maintenance necessary for the parameters involved. The temperature, humidity, and soil moisture sensors are linked to the Node MCU for data collecting, which subsequently linked with the IoT platform. This project successfully monitored the surrounding temperature and humidity, as well as the soil moisture content in the farm, by collecting data from sensors and sending it to the Azure IoT Hub through Wi-Fi, and the Power BI dashboard allows users to monitor real-time data on the web server. Finally, the project goals have been met because the finished product can monitor the surrounding temperature, humidity, as well as soil moisture content. This my reference for this project, as you can see. And thank you. If you have any question, you can email me or you can WhatsApp me in the number. So for the next, I will show a quick demonstration in real time how this project works. This is Microsoft Power BI connect to Azure IoT streaming. So this is running server. Then this query select IoT hub, temperature, fluid as temperature, and call stream Power BI. So this is a real time for the temperature, soil moisture, heat index, and this is the real time data lah.